Hi everyone, welcome to another episode of Rig Tech. In this episode, I am going to discuss about how to calibrate Texcope EZW2 new Tex EMI console. How the EMI consoles are showing the defect through the graph. This EMI can do only in ferromagnetic pipes. There is 8 numbers of sensors or shoes covered with the full circumference of pipe. When give the electricity to coil will energize with the magnetic power. That magnetic signals or magnetic flux will travel through the pipe. When there is a discontinuity, material discontinuity, magnetic flux will leaking or magnetic flux will come out. The shoes are passing or shoes are cutting. Shoe is a solenoid. Solenoid means it's a circle shaped coil is attached to a aluminum container. It's called a shoe. That shoes will cut, that coil will cut, or that solenoid will cut the magnetic flux. So then there is an electricity will produce. That small amount of electricity sent to console. Console will amplify the electronic signal or electric signal, then convert it to graph or graphical representation. Each shoes have their own amplifiers. Means each shoes have 8 single amplifier circuits or single amplifier sections that will convert it to the 8 shoes signal into graph. These are really happening inside the console. For to energize the coil, the console will give the power, and for drive the or buggy head, the console will give the power to drive the motor. I will introduce the console. The console will working with 1 ton AC current and all the body is metal. There is a power switch and 3 circuit breaker is also there. Drive, coil and logic. Then next one is male signal connector attached to the female cable connector. Next is drive connector. It's a female connector with 4 holes. The 2 is using to transfer the signal and 2 is vacant. That 4 connectors only 2 is using. And the next is coil port. It is a female connector with 2 holes. You can connect the coil cable with 2 male pin. Next port is 3-pin male port. You can connect the 3-pin cable, 3-pin power cord to the console. Console is always working with 1 ton power. If you don't have 1 ton power, you have to use the transformer. Isolated transformer is better than normal step down transformer. All the connector ports you can see in the left side of console. On right side of the console, there is only one control is there. It was mag control. One variac is there. It will help to increase or decreasing the mag current. In the clockwise, you can increase the mag current, and anti-clockwise, you can reduce the mag current. On top of the console have left side is transverse adjustment and right side is wall setup adjustments. There have left side is a transverse adjustment. It contains 8 numbers of potential meters to control the amplification of electronic signal, and there is 8 numbers of toggle switch that will help to on and off the shoes. Switch is on, the electronic current will pass to amplifier. Switch is off, it will not. And each potential meter is representing each shoes. There is 8 numbers of shoes are there. That 8 numbers of shoes are having 8 toggle switch to on and off the signal. There is a glowing LED or optical representation and audible representation that will notice which shoe is passing the threshold line. Threshold line I will explain you in chart section. LED will help you to find out the kicks passing the threshold line, and toggle switch will help you to on and off the shoes, and potential meter or potential control will help you to adjust the signal to achieving the kick height to threshold. And below of this section, 4 potential meters are there. One is signal conditioning system, SCS level. That will help the signal is passing beyond the, it will show on third section of graph. In graph have 4 sections. First is wall monitoring representation chart. Second is SCS section chart. And third is even number shoes. And fourth is odd number shoes. So that 8 shoes, 1, 3, 5, 7 is showing on the top of the chart. 2, 4, 6, 8 is showing the downside, means from bottom, third section of the chart. During the calibration, you can get it 4 signals on each section. SCS level, SCS gain. Gain is helping to increase and decrease the value. There is also 2 toggle switch that will help to show the line for adjustments. Normally, once you set the line, it will run always the same path. If you want to increase or decrease the value, you should run the chart, then hold this control, this toggle switch. Then it will show where the exact position of the line. Then you can adjust the control to increase or decrease, to go up or down the
SCS level.
And next is buggy control. These potential meter help to increasing and decreasing the speed of buggy. And the next switch is reset. It will reset all the functions. Next is coil control, printer control, and buggy control. 3 toggle switches there. It will control, first is coil, second is printer, third is drive. When you are going to run, you should start this order. First is coil, second is printer, and third is drive. Drive have this one toggle switch can act forward and base because it is a two-way switch. One is right side is forward and left side is reverse. Next is paper control or chart control. Push button will help you to release the chart paper, and this potential meter will help you to adjust the speed of chart. You can run the chart in fast condition or slow condition. If you are running slow condition, you can save the paper. You have to calibrate the same speed. Each graph have 4 sections. First is odd number, second is even number, and third one is SCS level, and fourth one is wall monitoring. And there have a small divisions. In each column contain 5 small dots. The height of each column is 25 mm. So the small divisions you have to consider 1 mm. The big section is 5 mm. Total 5 boxes you can see in the graph. That means it was 25 mm. If you keep in this calculation, you can easily achieve the calibrations, and you can easily interpret the graph also. The manufacturer is saying, in Newtech is saying, the each value is mils, means 1 mm is equal to 39.37 mils. Next is wall monitoring system. Buzzer on and off toggle switch, and baseline toggle switch, threshold line toggle switch, and baseline potential meter, threshold line potential meter, then gain and zero. That 2 potential meter will control the wall monitoring setup. 4 section shoes have each control. 1, 3, 5, 7 have one section, gain and zero. Then even number have shoe number 2, 4, 6 and 8 have 0 and gain control. And both section on and off toggle switch. These are the wall monitoring setup, and also they have in this location have the buzzer on and off toggle switch and buzzer. Buzzer is a audible alert and LED is a optical alert. Next is graphical representations, means graph. In graph have 4 section. First is odd number shoe indication. Second one is even number shoe indication. Third number is SCS level indication. SCS means signal conditioning system level indication. And the fourth one is valve monitoring indication. If you run on pipe, the pipe having no evidence of defects or transverse defects or pitting, cut, gouge, anything. If there is no defect, graph will move from left to right smoothly. If have any defect, there will be a kick, any cut or gouge or something. Defect you have to investigate later, but the mission will show you there is a defect or there is a material discontinuity. If have any cut, the flux leakage will come out. A shoe is crossing the flux leakage, then there will be producing a small amount of electricity that will amplify, and a chart will indicate you, chart will show you there is a something, some defect that you can get here. If the kick height is depend on the magnetic flux leakage on from the defect and speed of the buggy head, the speed of the buggy drive, and magnetic current of the coil. If you give more ampere current, the coil can produce more magnetic flux. So the more magnetic flux, if there is any defect, the amount of flux leakage will be high. Then here will get a huge kick. So always you have to investigate again what is that defect. In graph, which shoe is detecting that defect, corresponding, which light is glowing, the corresponding shoe is detecting the flux leakage. So you have to check that only that place. If your buzzer system is on, your buzzer is on, then it will that time will get a beep sound, or multiple LED will glow. Then you have to assume more than one shoe getting flux leakage. Means there is a defect. It was maybe half round cut or something. Means 2 or 3 shoe will pass defect. Then magnetic flux leakage will making the electronic current on shoe. That time in graph you can get it 2 or more kicks, and the optical indication will also show. The buzzer will also beep. So you have to assume more than one shoe crossing the flux leakage. Any signal is passing the SCS level, then that signal will register, or that signal will show on that third section, SCS level section. You can adjust the gain to increasing or decreasing the height of the kicks. Normally it will place on 10 mm, because when I am going to inspect the pipe, I will place above the threshold level. Then we can ensure that the signal is passing the threshold level. Which kick will pass the threshold? If the light will on and the buzzer will make a beep sound. The bottom section, the valve monitoring section, also have the threshold. Then which signal is crossing the threshold, the console will indicate to the inspector through optical and audible. Optical is 2 Two LED lights will glow on there and the beep sound will come.
It's okay. Don't want the crew.
Okay. morning. Good morning, sir.
Morning, morning.
Your last side.